folks, and welcome to this video where we're going to be talking about our most ambitious project yet.
Bringing together quite a few different things.
A lot of different things.
Yeah.
And the reason why we've got this 2005 Furby on the screen is because this is what we're going to base our project off. So we want to make our own Furby.
But bigger.
Yes. And we're basing it around the 2005/6 Furby.
These are my favourites.
Mine too.
Speech recognition in these, isn't there?
Yes. So we're going to talk all about that project in a little while. But first of all, I got a question in a comment on the video that we uploaded on this project, which was a project to heavily customise a Hedgies hedgehog. And as well as the aesthetic changes that we made, we also made some changes to the electronics.
Yeah, we replaced the nose button by a sound sensor.
Yes. So I got a comment on that video.
Oh yeah.
And the person asked how we got into this hobby. So Paul, how did you first get into electronics and how old were you?
Well, I don't know, it goes back very young, to when I can remember, sort of like 5, 6 years old. I'd have toys, the toys would break, and then I'd take the toys apart. Just naturally, and have fun with them. And, I remember having something like a little merry-go-round when I was about 6 years old. And I think the top came off and it was only about as big as your hand. And there was this spindle that came out which was still going around. I remember trying to use it as a drill in soil. So, yeah.
That's funny.
From very early on. And then it developed into electronics when I was like 10 years old.
Because your parents used to buy you sort of books on electronics, didn't they, for like presents, birthdays and things?
No, I used to buy those myself because it was
I'm sure you said that your parents did buy you.
I mean, my mum and pa, when I was about 12, they got me like one of these Tandy electronic sets. Tandy's used to be, I don't know if it's still in existence, an American outlet, and they had shops in the UK. And they sold electronic gadgets which were a bit different and interesting at the time in the UK. You couldn't really get things like this other than from Tandy. So it was like 150 in one electronics project sets that you would connect components together with wires and spring clips, and you could make things like a crystal radio or make a light flash on and off and things like that.
You still remember that?
Oh yeah, that really accelerated my electronics learning, that and also forged a direction for me in life, like through like college and later at work and that.
So we'll talk about college, what you did there, in a few moments. But right now, I'd like you to explain what we've got on the screen here, because this is something that you've made.
Yeah. So, I mean, this Furby we're making, this is going to be a bigger Furby based on the 2005, isn't it?
Yes.
One of the reasons why it's going to be bigger is because bigger things are easier to make.
Yeah.
Okay. So we're bringing together a lot of different things for this that you've learned and improved your skills on, and that I've learned and improved my skills on over the years. And we'll be using a lot of modules, like ready-made modules, like we did for this little Hedgie, like with sound module, and also 3D printing. So This thing here is something I've been playing around with recently.
Now, the gears on this were done on a resin printer, but you only got a resin printer for Christmas, so you haven't had one very long.
Yeah, because they're quite cheap now, resin printers, especially if you get a beginner's one. You can get one for about 160 quid, which is really quite cheap in the world of 3D printing. So yeah, the grey gears in there are something that I designed, but using somebody else's sort of like, it's like something called OpenSCAD. It's like you just type in what sort of size gears you want and it produces them for you. So we're sort of building very much on the shoulders of other people, aren't we?
Yes.
In a way. So whilst this is my design, the gears are based on somebody else's sort of OpenSCAD scripting program. So the gears are made of resin. The green stuff is made of on a filament printer, so like the bits that hold it all together, and the black rods are just bits of carbon fibre that you can get off a tube, like rod that you can get off eBay, and it's got a little electric motor. Oh, I don't know, something we got on eBay for something else. So let's just power this up. So this is a motor which is geared down with those grey gears, and then there's a mechanism in the end, which is like a cam mechanism, which turns it into linear motion. So we're thinking of maybe using something like this in our Furby to operate the ears or the feet or something.
I think, no, we're not going to have moving feet. We'll have moving ears.
Ears, yeah.
We thought it'd be good to have a sort of more, how would you describe it, mechanical clockwork mechanism.
Yeah.
Because it doesn't have to be accurate. It's just to give some animation. So we thought we could use this sort of principle
to move the ears.
Moving the ears.
There'll obviously be a microcontroller at the heart of this Furby, like an Arduino microcontroller, because a lot of things will need to be controlled, such as that mechanism you can see moving there.
Yeah, when to turn the motor on and
when to turn it on and off. Yeah, it'll be controlling.
And how fast?
How fast? Yeah.
So we'll be talking about this little thing that I got and put together.
That was a toy meant for youngsters to learn principles.
Well, it helped me learn a principle.
It helped me as well.
About cams.
Yeah.
So we'll talk about that in a bit. But I want to go back to how you developed your interest in electronics. And we're talking about college now. So I think you were 16.
Yeah, when I left school, I went straight to college. I went to a technical college and I studied electrical, electronic engineering, mechanical engineering, up to sort of like technician level, really. Not really engineering level, but technician level.
So how many years was that?
That was, I think that was a couple of years. It was a great course because it mixed sort of electronics, which I was interested in, of course, with electrical engineering, like heavy electrical engineering, which
a bit of mechanical, wasn't it?
Mechanical engineering as well, and physics, and a bit of material science, and a bit of chemistry, yeah. So it was very mixed. I think it was called something in technology, O&D in technology, if I remember rightly, because you're going back to 1980, 82 now.
And then what did you do after that was connected to electronics?
What, you mean as a line of work?
Well, did you go into work then, or did you carry on with your study?
Okay, yeah, I had a few sort of like technical jobs, sort of technical assistant in the pottery industry, doing various measurements. That was
Royal Dalton, wasn't it?
It was, yeah, when we used to have a pottery industry in the UK.
Stoke-on-Trent.
That was lab-based work, mainly using thermocouples on kilns and things like that. Then I worked for BT for a while. Then I worked for Siemens for a while in a sort of office engineering environment.
So you did do further study, didn't you?
Yeah, I went back to college to top up my sort of technical qualifications to a higher level.
How old were you then?
I'd be sort of in my early 20s then, and I think it was mainly electronic engineering, electronics basically, and control engineering, which is sort of like how to control industrial machines and processes and things like that.
So that was through sort of conventional study and through work, but most of what you've learned has actually been through you just furthering your hobby.
Hobby-based, yeah. I mean, as soon as micro computers, home computers were available, I got one. I think that was in 1982. I think it was an Acorn Atom. And I learned a stack about basic programming and a little bit about machine code programming. But that really fired my interest in computers, because I could see how computers blended with electronics for controlling things. So, yeah.
You did have some models as well, though. I mean, didn't you have like a radio-controlled car, I think you told me about, and some other things?
Yeah, of course, as you get older, and you spend your pocket money on different things, I've got, obviously all lads my age, I think, would have had Airfix kits, and a natural progression for me was to get sort of like kits that were powered and radio-controlled. So I used to have a great deal of fun with radio-controlled cars, sort of making them up from kits and breaking them and then changing parts on them and things like that. It's pity 3D printing wasn't around then, but that would have been an interesting blend.
And you also fixed a lot of things, didn't you? You know, when your parents had things
Yeah,
broke.
that's right. I mean, obviously, you know, all this time from being a little kid, even up until now, I still take things apart to see how they work. And of course, when I was younger and living with my ma and pa, as household appliances used to break, I used to take them apart, and sometimes I'd fix them to the surprise of my parents. And then they used to ask me to try and fix more and more things. And so, you know, like microwaves, and I remember microwaves, or my mother would knock a clock off and it'd smash into a million pieces, and I'd put it back together and it'd still work. Or radios. They were just, you know, they're just simple things. Like you'd take a radio apart and, you know, like I'm talking about an old-fashioned early transistor radio now, and you'd see all these components in there. And then sometimes you could just see why something wasn't working. It would be a mechanical thing. Like you could see a solder joint with a crack in, and you'd realise that, you know, oh, I've just warmed this up again with a soldering iron. That repairs the solder joint, and it might work, and very often did work again. And then as my knowledge of electronics increased, of course, I'd buy things like multimeters, and I'd, you know, understand a little bit how components work, like transistors and that. And your knowledge just carries on increasing naturally because you've got a natural fascination with these things. Even now, as I say, I take things apart, yeah.
And I know as long as we've been together, you've fixed quite a few different things that we've had that's broken. I know you fixed a bread maker once.
Yeah, I remember a bread maker, yeah.
And you fixed a dishwasher?
Yeah, the bread maker was interesting actually, because as you take things apart over the years, you get to see how manufacturers cut corners on making things, and all use cheaper components and that. Sometimes the components in a bread maker, for instance, if we just look at a bread maker, they're very good, like the motor on them is quite good. But I remember this bread maker we had that failed. Some of the transistors were sort of like underrated for the job they were doing. So I'd repaired those, and it worked again. Yeah, I remember that a few years ago. Yeah.
We'll get back to your interest in electronics and how it developed, because we'll talk about sort of test equipment that you've got over the years, because you've got some since we've been together as well. Quite a bit, actually.
Quite a bit, yeah. Is it a bedroom I sleep in, or is it like a test equipment room? Yeah.
But first of all, we'll have a bit of a chat about this thing.
Oh, yeah.
So I got this for myself as a way to try and learn some basic things.
Mechanical things, maybe, wasn't it?
Because over the years, I kept getting frustrated, really, that I always have to ask you.
Yeah.
For every little thing.
The thing is, you being a girl, and the period we've come from, what you got taught at school and the direction you were pushed, like in college and further on, was in a very different direction than young boys and men were pushed in. We were pushed
it's like
more
the craft. Yeah. It's down the craft line.
Yeah, that's right.
So, but I'll talk about that later.
But not the engineering line, not mechanics, not electronics and things like that.
So I just had this idea about getting something that was like just for a kid to put together, and I thought I should be able to manage that. And I was really pleased that I did like 99% of this without any help from you. It's just a couple of things where I couldn't understand the instructions or something like that. But I was really chuffed that I was able to put it together myself.
And I noticed when you were doing it, because you've done more than one thing like this, your sort of manipulative and dexterous skills have improved greatly. Just the idea of being able to name various things helps you to understand the principle of operation of how you get rotary motion, how you get linear motion from a cam, from a rotary motion motor.
So that's what this is all about. It's just got the one motor in it, basic motor, and it's using cams in order to transfer that rotary motion to a linear motion for the eyes and the mouth.
Cams and gears, yeah.
Cams and gears, linkages. So,
But the main thing is it's just got a motor which goes around very fast, and yet you get all this different subtle movement out of the eyes and the mouth.
And putting it together, and the size it is, and because it's quite simple, it really helps you to understand how cams work to do that. So Just switch it on. So the eyes move from side to side and the mouth moves up and down like that.
So sort of vaguely reminiscent of a Furby in that you've got eyes and a mouth and there's some movement there, animation.
So you actually used this for making this mechanism here, didn't you?
Yeah, I'd made gearboxes before, but I'd never really done anything with them. So I decided, after seeing Jude's kit, I wonder if I could copy something off there to put on one of my gearboxes to change the motion, from something that just spins around to something more interesting. So I looked at how the cam worked on Jude's model, and I thought, I can copy that in 3D printing, because it was very simple. So I made this little mechanism to go on the end of the gearbox and made this nice sort of like slow backwards and forwards linear motion, which we thought could be very useful in a Furby. So lots of things coming together for this Furby project.
Yes. You were saying, like, by changing the linkages, you can get, different sorts of movement.
Yeah, we should be able to get the ears to twist or twiddle or bend forward or something like that. Whatever we want, really. Whatever we decide on in the end.
And we're going to have a really interesting eye mechanism. So we're going to talk about that in a little while. But first, we're going to get back to talking about how your knowledge of electronics developed over the years. And pieces of test equipment.
Yeah.
Now, you bought a lot of test equipment since we've been together.
Yeah, as I've had more pocket money. I watch videos on... That's another thing as well. I watch videos on YouTube. And I
that's
learn,
a recent thing, isn't it?
Yeah, I learn so much from other people who are far more knowledgeable than I am. And I could only aspire to be like them. So I learn a lot from other people. That's an important thing, really. But yeah, experimented myself and buying more test equipment. Like I bought a scope as those became... A lot of those test equipment has become cheaper as it's become digital.
Yes,
so I bought a digital scope and I learned so much by being able to sort of see... With an oscilloscope, you can sort of see the waveforms that are going on inside circuits, and it really improves your understanding of what's going on inside simple and complex circuits.
Because you used that recently with a SCSI to try and work out what was going on with the sensor in the mouth.
Yeah, so you recently got one of those, but it didn't come with food, and it's always been crying for food. So we were trying to work out what the sensor was in the mouth that would pick the food up. So I used the scope to investigate that. We got quite a bit of information from the oscilloscope, which gives us a much better idea of what the mechanism is that operates inside the SCSI's mouth to enable it to identify the food. But that's sort of ongoing, isn't it?
Yeah. Okay, so I think that about wraps it up for a bit of a history there.
Yeah.
How you developed your interest in electronics and how it's progressed over the years. So the guy who
designed
this. I'll put a link to his page where he shows you. He's got all the files you can download.
So the 3D printing files and the instructions to how to put it together and that. Yeah. So there's a lot of prints. A lot of prints need to come off the 3D printer. As you can see, that's just some of them.
You've not printed it all out.
Not printed it all. There's only about 30% of it there. So once that's assembled together with these, which are just cheap servo motors...
You need 6 of them, don't you?
We need 6 of these. It'll give us a mechanism that'll sit inside our giant Furby. That'll allow us to control the eyes, left, right, maybe up and down, and also blinking eyelids. And all that will be controlled by an Arduino as well.
Yeah, so they should be similar to this Furby's because they've got eyelids on top and below.
Yeah, that's right.
Like this Furby. But they're larger.
Yeah, and the Furby's going to be larger in proportion to the eyes because we've allowed this particular mechanism for moving the eyes is going to be the main feature, really, isn't it? One of the main features.
Oh, yeah.
And we've allowed that to dictate the scale of the Furby. Yeah.
Yes. So what we will be doing is we will assemble the eyes and then try to make the proportions of everything, like the mouth and the rest of the head and the body, proportionate to the eyes in the way that the proportions are in the 2006 Furby. So you can see it's going to be quite a bit bigger.
Yeah, so probably what, twice as big maybe? Up to twice as big.
I don't know, are those eyes twice as big?
They get it on for twice as big, aren't they?
I mean, you can measure them and then we'll have more idea, won't we? We'll be taking measurements. Obviously, we're going to try and get some eyes that are going to look like these.
Yeah, so will you be maybe using those and painting them, or are we just using those as placeholders at the
I
moment?
think we're just going to use these just to sort of have something to work with first. I don't know if I'm going to buy some glass eyes or what yet, or if we can try and make them out of resin. It's going to be a learning curve, I think, with that.
Yeah.
So we'll talk about some other aspects to do with this project after I've very briefly mentioned what got me into this hobby. So when I was a kid, I always liked toys that would do something.
Yeah.
Though it was a lot more limited in the 1970s.
It was, yeah.
Because you only really had sort of clockwork type mechanisms, because you didn't have microcontrollers then, did you?
Not in toys, no. And I'm not even sure they had microcontrollers full stop there.
I always remember the Basil Brush show.
Mm-hmm.
Basil Brush would occasionally bring on his dog,
Yeah.
a little dachshund.
Mm-hmm.
It was a little toy dachshund that would yap and wag its tail.
Yeah.
I think it could sit.
I remember that vaguely, yeah. Yes.
And I really, really, really wanted one of these little dachshunds. And so I did get one for Christmas.
You didn't?
I did.
Oh, you did?
I got one for Christmas.
Oh, look at you.
Well, I wasn't so lucky because I was playing with it outside and I forgot to bring it in.
Oh.
And it got wet and it ended up in the bin.
Oh,
and
no.
I cried.
What a tragedy.
Yeah. But I always liked things that would do something.
Yeah. I think most kids do, don't they? Whether it's wind up or battery powered. Yeah.
I don't know. I mean, some kids collect stuff that is just like bits of plastic that do nothing at all with no electronics.
Nowadays, that seems to be the case, yeah.
And I never really lost my love of toys, ever. When my nephew was little, about 4-year-old, 5-year-old, me and my mum used to go and babysit him. And I used to play with his toys, and this is when I was sort of like 13, 14, 15.
Right.
And I know my mother would have this smile on her face because I was entertaining my nephew, and I wasn't really, I was entertaining myself.
Yeah.
Because he had some great toys. I still remember them now. He had some of those pullback cars, but they were like really mental. You can make them go really, really fast.
You sort of pull them back and you build up
and
the
like
energy in a
slam
flywheel.
into the
You
wall.
let them go, they go screeching off.
Really violent.
Banging into the kitchen cupboards. Yeah, I know the sort of toys you're on about.
And I've always liked going in toy shops. And toy sections of shops. It's like, if I go into a shop and there's a toy section, I've always drifted over. And even before I started like buying stuff for myself, I would still always drift over, and I always automatically press buttons on toys.
Oh, and they've got them in demonstrations to try them out.
Especially when you get them for like really little kids, and you've got these nice big buttons on, like penguins that'll go over like a bridge or something. Always. And then I started to collect some plush quite early on as an adult, and then it just led from there.
So you moved into the realm of collecting, really?
Yeah, with plush initially.
With just plush. So then it developed into animatronics from plush.
Yeah, because I've always been interested in things that would do something.
And I think Furby's in particular, this 2005.
Well, that was one of my first animatronics that I bought as an adult collector.
But it's been one of our favourites, both yours and mine. It's so eccentric and rude. And
rude? What do you mean rude?
Well, it can be very rude sometimes.
I think that's 2006.
Is it?
We've got that video where it wouldn't go to sleep. That
Right.
was a 2006.
It seems-
It was
it-
belching at me.
It seems to have a dry sense of humour as well.
This one, the mouth is really gone on it.
They don't last. Unfortunately, the plastic, whether
It
it's
loses the plasticizers.
on the beak, on the soft plastic, and the hard plastics tend to disintegrate after so many years as well.
Well, this one, the reason why we've not got it switched on is because this, along with all of our 2005-6 Furbies, they've all broke, various bits have broken on the bottom. We used to make replacement battery covers for these because the
That's
battery
right, yeah.
covers all break, don't they,
Yeah, we made
themselves?
Quite a few
But now we
thousand of
can't
those.
even put the battery cover in because the bottom itself needs fixing before you can put a battery cover in.
So you were saying how you got into collecting these, and now it became more narrow into just the animatronic realm.
And the craft thing, I've always liked making stuff. So when I was a little kid, I would just, because my mother worked in a clothing factory, there was always like material and cotton
Oh,
around.
right, yeah.
So I used to try and make stuffed toys and stuff. I've always liked working with my hands with crafts. I really enjoyed when we had pottery at school, but it wasn't pottery on a wheel. You just made it, shaped it with your hands. I made this little badger family. So I've always, and I liked art as well, drawing and painting.
I see where the influences have come from in your past then.
Yeah. So now I try to work on the sort of craft aesthetic side of these models, and you work on the electronic side.
And your craft side is involved using many different sorts of materials
Yeah,
now, isn't it?
learning with different materials.
Like silicones, fabrics, paints, all different sorts of
Latex.
glues, latex. So yeah, many
And
different
flocking.
materials.
Flocking as well.
And flocking, indeed. Yeah, that's right.
And one of the things that I recently sort of worked with was wadding and making a shape for a body with wadding.
Yeah.
And
That's sort of like
stuffing.
building up the flesh, so to speak, before you put the final skin on. So you're giving it the
So
shape, aren't you?
The project that we're going to be working on, making a Furby.
The Furby, yeah.
The workings of it is just going to be like in a rectangular box, because the shape of the Furby I'm going to get by sort of sculpting with wadding
Yeah.
to give us the shape and then cover that with fur. So finally, let's talk about what those workings are going to be. So we've talked about the mechanism that we're going to have for the eyes.
We have, yeah.
And the mechanism we're going to have for moving ears.
The ears.
We think the mouth, we're probably going to use a servo for that.
Yes.
Because we want the mouth to move when it talks.
All these movements will be coordinated by an Arduino. But carry on, yeah.
And the biggest thing in it is going to be, most important thing, is going to be voice recognition module.
Right, yeah, you can get a number of different types of voice recognition module nowadays. I think you've scoped out about 10 different ones.
Yeah, there's a lot of them now.
So
quite cheap as well.
There'll be a voice recognition module. Again, that'll interface with the Arduino. And there'll be also an MP3 module that will play sounds, what the Furby says and the sounds it makes. An MP3 module, those sounds will be on an SD card, and that will be under the control of an Arduino as well.
So, whereas there's only a few things you can say to this Furby that it understands, should be a lot more with using the voice recognition module.
So the thing that'll make it seem like a Furby, apart from the appearance and apart from the sounds, will be the way we code up on the Arduino to make everything work together in a Furby-like way.
I want to get some sort of app or software that can change your voice. So what I want to do is
so you're not about changing the pitch or distorting it and trying to make it sound more like a Furby. Yeah.
So I'm going to try to imitate the Furby anyway.
Because you can do a pretty good Furby impression, can't
Well, you think so.
I think it's pretty good, yeah.
So I'm going to try and imitate the Furby's voice, but then use some sort of voice distorter
To-
to try and make it more like a
And to
Furby.
disguise the fact that it's been a human being that's
Yes, yeah,
originated
yeah.
the words, yeah.
Yeah, but it's this Furby's voice that I'm going to try and
Yeah,
mimic.
of course, the best voice out of all the Furbies, I think.
Cutest.
The cutest, yeah.
And the mouth, maybe we'll look into maybe trying to make some sort of flexible beak, because we've been working with silicone and we've been working with
Yeah,
latex.
it'll probably have a 3D hard structure underneath, and
Because this has got a hard plastic beak underneath.
it has, yeah. And then hopefully you'll be able to craft something out of latex or silicone, like you say, to put over it, because it's one of the most important aspects of a Furby, isn't it?
Yeah, its mouth.
Its mouth.
I do want to try to fix that aspect of these Furbies, these original Furbies. Try and make fresh mouths for them. Because some of them, the mouth has gone completely.
Yeah, that's right.
So,
Although they're very difficult to replace parts on, because they weren't really designed to come apart, were they?
well, they weren't, but I've just got this vague idea of like trying to mould something over the plastic beak itself
Right, okay.
that's inside.
Okay.
So I think that's about it. I think we've covered everything that we intend to do with this project.
So it's going to be the biggest project we've attempted so far.
It's a very ambitious project.
But not too ambitious, I don't think, because everything's modular. And we have limited the scope of it. So I don't think it's too ambitious, and we use all our skills that we've honed so far.
So, folks, I hope you found that interesting to some degree, and I hope you're as excited about this project as we are. And we'll be back with an update as soon as we've done some more work on it. But that's it for this video, folks. Thanks for watching as always, and hope to see you next time.